Welcome back, and we're on to day 4 of 5 of the IMT challenge paper. So a paper taken by a lot of students in the UK. The knowledge required is actually a bit less than GCSE, so it's actually a good set of questions for everyone to try, relevant to when you went to school or how long ago that was, just because they test lots of different skills. Now, to be clear, these questions now that we're onto the harder questions. So only 3 questions today, 2 questions tomorrow, and I would suggest about 4 minutes, so not much longer if you want to be keeping up with the time limit you have for the paper itself. So let's go. So first question coming up in 3, 2, 1. Okay, so nice question to start. I like this one. This one is, as ever, when you're dealing with circles, it's a question about finding the radii. So what does it want me to do? Well, it wants me to find out the shaded area, or more notably, what fraction of the big semicircle is the shaded area. So I'm going to need to find out the area of the big semicircle, the area of the small semicircle, and then find some sort of difference between the two. Whenever I'm doing this, as I've said already, I need to think about what the radii are. It already tells me in the question that the radius of the big semicircle is 2. So I can put that one in. Then I need to think about how I can get the smaller semicircle. So basically I'm looking for clever ways of drawing either triangles or different shapes that bring in the smaller semicircle. So let's just write down what we have. So we have the larger semicircle has a radius of 2, and I'm going to say the smaller semicircle has a radius of rs, or r subscript s. And then I'm going to think about this triangle here. And the reason this one works well is for a couple of reasons. Firstly, I formed an isosceles triangle because I know both these lengths of the radii of the small semicircle, so they are the same. I also know this is the radius of the large semicircle, so I know this one is 2, which means I've got a fairly simple triangle that I can set up. So I've got a right angle triangle, isosceles, I know the hypotenuse is 2, so therefore it must be the case that 2 lots of rs squared must equal 4, rearrange it, and that tells me that rs squared is 2, or in other words, rs equals root 2. I've found everything I need to find out areas of circles. So the rest of it is then just pulling it all together. So the shaded area is going to be, so let's do it step by step. So the shaded area is going to be the area of the big circle. Now, I will say at this stage, I've kind of done whole circles because the semicircles will cancel anyway, so that's fine. Well, technically I should do half of these values, but let's continue. So the area of a whole circle, which is pi times 2 squared, take away pi times root 2 squared, and divide all that by, because I want the fraction of the larger semicircle, pi times 2 squared. And again, I've kind of implicitly cancelled all the 2's, which isn't ideal, but if I'm doing this in an exam, I just want the quickest route possible. Then I do some cancelling, so that gives me 4 pi minus 2 pi over 4 pi. Pi's cancel, and that just gives me a half. And a half is indeed one of my answers. It's answer. This one is answer B. Not too bad. Next question is coming up in 3, 2, 1. This is my least favourite question on the whole paper, because one part of it, so either I'm missing something, and please do let me know in the comments if I'm missing something obvious because I can't see what it is, or the question is just one of those questions where you just have to try different numbers, which I don't like because that doesn't feel very mathematical. Anyway, let's set up what we've got. So we are told that we have a diagram. It tells us the perimeter of the small rectangle, tells us the perimeter of the medium-sized rectangle. So there's my position here. I'm going to label the sides A, B, D, C, as you can see in the diagram that I've got. And because I know the perimeter of the small rectangle is 12, it must be the case that 2C plus 2D is 12. I can do the same on the medium-sized rectangle, so 2A plus 2B is 28. And I can cancel both of those by 2, and that tells me that A plus B and C plus D are 14 and 6 respectively. I also can go an extra step, so I'm still really not sure what I'm doing with the question. I'm sort of playing with different ideas here. So I would note, because it tells me in the question that they are integer side lengths, C and D can only be 1 and 5 or 2 and 4. That may be relevant coming up, but I've written it down anyway to help me. Then the large rectangle, well, the perimeter here is going to be A plus C plus B plus D. In other words, I'm adding them all up and multiplying them by 2. Well, what I do know from above is, as I say, 2 lots of A plus B plus C plus D is the things I worked out above, 14 plus 16, which is 20. So therefore the overall perimeter is going to be 40. So far, so good. Then it says, which of the following possible numbers could be an area of the original rectangle? Now, I am drawn to a number here, and I'm drawn to the number 96 simply because it has lots of factors and seems to divide quite well, whereas 98 is 2 times 49. I mean, I know there's other factors. It doesn't feel quite as neat as, let's say, 96 does. So that was kind of my instinct to go with that one. So what I've done is I've set up the area, which is a plus c times b plus d. And then really I've thought about the number 96 is 8 times 12. And I can think of an AC and a BD, which gets me to those numbers. Because if I have A is 6 and C is 2 and B is 8 and D is 4, that satisfies all the requirements I've got above of 6 and 14. And so therefore that means if I multiply these numbers together, I do indeed get 96. It feels quite unsatisfactory, I have to say. It doesn't feel like it's fallen out quite nicely with a lot of logical reasoning. But as I say, if you've got a better method, do let me know in the comments. I would really appreciate that. All right, next question coming up in 3, 2, 1. So we're back to the nice questions. Again, you hear me say this quite a lot, which is why I use this question. So almost by definition, I like this question. Regular hexagon. So regular hexagon has one main thing about it, which is it is made up of 6 equilateral triangles. So I'm going to draw the diagram itself, and then I'm going to note what do I need. Well, this shape here is not a square, it's a rectangle. So therefore, if I think about the square, and this is a diagram looking, so the square is the sort of red square, obviously. And then what I'd note is there's 2 equilateral triangles which meet in the middle. So in order to work out the area of this shaded rectangle, well, I know what the length is because it tells me in the question the side length's 2. I'm really just trying to work out what x is. And the way I can do that is I can do 2 lots of squares and then take away the lengths of the triangles, and that must be the difference of x. So I'm going to consider it bit by bit. So let's consider the triangle itself. So here's one triangle. We're back to something we've done quite a lot in these various videos I've posted, which is I can calculate h by using a half the base of the triangle, Pythagoras, 2 squared minus 1 squared, and that tells us that h is going to be root 3. Really common sort of number that comes up in these exams. I know that 2 times h is therefore 2 root 3. So again, I'm sort of working out what the total height of the triangles is. And therefore it must be the case that x is going to be, well, again, let's walk through what I've written down here. So I've got my 2 root 3, which is the 2 triangles, minus 2 times the square lengths, which is 4. So in other words, I've factorised already. It's going to be 2 lots of 2 minus root 3. So the area is just therefore 2, which is the base, times the 2, times the other 2 minus root 3, and that just gives me 8 minus 4 root 3. It's quite hard to describe that, but again, work your way through, it falls out quite nicely. Either way, the answer is up there. The answer is E, so I'm quite comfortable the answer this one is going to be E. And that's it for today. 2 notably difficult questions tomorrow. The final one is definitely quite a bit more challenging, so come back for tomorrow for the final part of this week's questions. And do leave a comment down below, especially if you've got a better way of doing the previous question. And as ever, like the video because it helps the video get in front of other people. Thanks all. Bye.